Okay, so Homer's got a shower. It's all slimy. He wants to know if coconut juice is going to help out. His initial observation is that green slime on my shower. The control group with the coconut juice or no. Here's his shower, right? He divides it in half. Okay. I mean, he's got, is that green right there? Okay. So he's got green slime all over this stuff, right? Let's say on side A, no coconut juice. On side B, coconut juice. What's the control group? A. Right, with no juice. Okay, side A. Okay. Independent variable.
The coconut juice.
Yeah, the presence of the coconut juice, right? The dependent variable, what is he measuring? What is he observing? Yeah. The green slime, or the amount of green slime, right? I can measure that in many different ways. I can take pictures, I can take videos, I can scrape it off and weigh it by mass. Okay, I can shine light through it and have a sensor on the other side of the door and see if the amount of light that is going through the slime is increasing over time. There are many ways to collect that data, either qualitatively in pictures or video, or quantitatively in some sort of number form. So what should Homer's conclusion be, since there is no difference? Yes?
The green slime didn't go away.
So what was he trying to prove, though?
The coconut juice worked. It didn't work.
The coconut juice has no effect on the removal of green slime versus water. You got Bart, he's trying to he's trying to microwave mice, because that's what Bart does. He puts these mice in the microwave for 10 seconds. 10 mice in one and 10 mice in the other. Well, he microwaved 10 of them and didn't microwave the other. And he wanted to see if they would move this block of wood. He found that the ones that he microwaved move 8. 8 of the 10 of them moved the wood, or the ones that he didn't microwave, only 7 of those mice were able to move the block. Control group. What was this control group? Which mice? Microwaved or not microwaved?
Not microwaved.
Okay. Not microwaved mice. Independent variable.
Microwave.
Yeah, exposure to microwave. Okay, what was the dependent variable? What was he measuring? He wasn't measuring strength. What was the data? It was the number of mice that could move. He wasn't measuring. Strength would be measured in, force, right? He's just counting the number of mice that were able to move the block. So if he puts something on the clipboard that says 1 or 2 or 3, what does that number represent? It doesn't represent strength. It represents number of mice. The data is in the unit of mice, not strength, right? So he's counting mice. That's the dependent variable. So what should his conclusion be? 7 out of 10, right, were no microwave. And 8 out of 10 were exposed to the microwave. Does that support as evidence that the microwave increased the strength? Yes or no? No, why not? It's not statistically big enough of a difference. There are statistical tests that we can put into place, and we do that in science, where we figure out whether or not the difference between the two groups was because of the variable or because of just dumb luck. We call that in biology a chi-square test. And in my AP biology class, when we perform experiments, once we collect our data, we then have to perform statistical tests to that. And if you were to perform a chi-square test on this, you would notice that there would be not enough of a difference for it to support or prove the hypothesis, or the claim that there is a difference. Yes?
So for this one, what would be a big enough difference to show that?
You'd have to do the math, right? There'd be, it's either, you'd have to perform a test where the number would be over, the chi-square test is you take the number that you observe versus the number you expect to get. If there was no difference, you square it, you divide it by the number that you expect to get, and you add that by how much data that you have. And if that number is above a specific critical value, in this case it's probably 3.8, right? then you would say, yeah, I accept, or no, I reject the null hypothesis, which is if there is any difference between my observed and expected data, it's due to just chance. So in this case, I don't know exactly what that number would be. I'd have to do the math. Probably like, I don't know, a pretty significant difference. Maybe 5 or 6 more. How could his experiment be improved? Just give me 2 things that it could be improved. Yes? Multiple trials. What else? Same mice instead of different mice. Maybe the 10 mice were stronger or weaker. Yeah. What else? Oh, so make sure that both sets of mice were at least at one point exposed to the microwaves. Good. All these things are good. Is there probably a better way to test strength than move a block? Yeah. So Krusty want to know if his itching powder was better than normal itching powders. He claims that it can have 50% longer lasting itches. So he buys the itching powder and compares it to the usual itching powder. Subject A has the original itching powder. Subject B has the experimental itching powder. So which is the control group, A or B? What's the independent variable that we're testing? No, what is it that we're testing? Yeah, the exposure, the new itching powder, which is, placed on person B. What's the dependent variable? What is Krusty the Clown writing down on his clipboard? What is he observing? What is he measuring? Yes. Time spent itching. So your units are going to be in seconds, right, or minutes or something like that. So person with normal, 30 minutes. Person with the new, 45 minutes. Does this support his claim that it's 50% longer? Yeah, right on the dot. 50% of 30 is 15 minutes, and 45 minutes happens to be 15 minutes longer. So yes, it does support it. This last one, you guys, there's a lot of different ways you can answer this. She wants to know whether or not her Rugudi, which is some hair product, will affect the speed of hair growth, the rate in which you grow your hair. How could you, or Lisa, perform this experiment? Somebody give me one example. How would you test this shampoo product and whether or not, yes? Okay, so go a month with your hair growing without the shampoo, and then start shampooing your hair, and then, every day measure the length of your hair growing, and then divide that by the same amount of time, then you'll get the rate of hair growth. Now, the second month of your hair as it's growing is going to be different than the first month because your hair at the first month is shorter than the second month, right? So that may affect the rate of your hair growth. So, and there's only one person, right? And it's going to be at different times of the year because the first month was in one month and the second month was in the next month. Who knows what you were eating in the first month when your hair was growing? Maybe the diet was different in the second month. Can you see all the possible flaws with your experiment? It's not easy, right? Designing an experiment where you have to maintain the constants between the control group and the experimental group. And then make sure that the data that you're collecting is in fact actually measuring what it is you're trying to test. Which in that case, you would be collecting perfect data. The amount of hair grown over a period of time, which is the rate of hair growth.